In this section, we're going to talk about cofunctions. So what are cofunction identities? In an earlier example, we noticed that when we have two angles, alpha and beta, that are complementary, meaning that they add to 90 degrees. So we said alpha plus beta was equal to 90 degrees, and I would say that we could probably add the statement here that if we're in radians, 90 degrees would be equivalent to pi over 2. That if our two angles are complementary, then the sine of one of those angles is equal to the cosine of the other. And I think specifically in this triangle, the sine of alpha was equal to the ratio of the side across from alpha, which was 4, over the hypotenuse, which was 5, and the cosine of beta was equal to the length of the side adjacent beta, which was 4, and the hypotenuse, which was 5. So yes, they do equal each other. But why is that true? Well, if you go back to this definition of complementary angles, and instead of writing alpha plus beta equals 90 degrees, if I solve for beta, I would get that beta is equal to 90 degrees minus alpha, or I could say beta is equal to pi over 2 minus alpha. Now, what does that do for me? Well, I said that the sine of alpha is equal to the cosine of beta. But I now know that beta can be rewritten as 90 degrees minus alpha, or if I'm in degrees, it can be, or excuse me, if I'm in radians, it can be the cosine of pi over 2 minus alpha. Now, what that does is it's another way of writing this relationship where I'm only working with having to know the value of alpha. I only have to know the value of one angle instead of having to know something about alpha and beta. So here is the formal definition. In general, in a right triangle, when alpha and beta are complementary acute angles, then their cofunctions are equal. And what are cofunctions? Cofunctions have a co in front of them. So we've seen those. Sine and cosine are cofunctions. Secant and cosecant are cofunctions. And tangent and cotangent are cofunctions. So specifically, if you have the cosine of one angle, that is going to equal the sine of pi over 2 minus that angle. Or if you prefer, we'll start with sine and say that the sine of an angle is equal to the cosine of pi over 2 minus that angle. Now keep in mind that if we are not in radians, instead we are in degrees, then it turns into the sine of 90 degrees minus t, or the cosine of the quantity 90 degrees minus t. So we're listing these in terms of radians, but 90 degrees and pi over 2 are equivalent. And the same thing can be said about tangent and cotangent, that same relationship, and then also secant and cosecant. Let's look at an example. In a right triangle, the cosine of 55 degrees is equal to the sine of what? So we know that sine and cosine are cofunctions. So the cosine of 50 degrees is going to equal the sine of 90 degrees minus 55 degrees. And we can take that one step further. Let me just write this down below. So the cosine of 55 degrees is equal to the sine of, let's see, what's 90 degrees minus 55 degrees? I think that ends up being 35 degrees. So if I knew the cosine of 55 degrees, and if I knew the sine of 35 degrees, those values should be the same. And are they? So I put this into my calculator, and it turns out that they are 0.57357. That was the cosine of 55 degrees. This one is, it's a little bit hard to see, but notice up here on this TI that I was in degree mode, so that's why you don't see the degree on there. And that's the same thing as the cofunction. Now, a variation of this question could be, in a right triangle, if the cosine of 55 degrees is approximately 0.574, then determine the value of the sine of 35 degrees. So if that were the case, then I might write something like this. The sine of 35 degrees is equal to the cosine of 90 degrees minus 35 degrees. And 90 degrees minus 35 degrees is 55 degrees. And it was given that that was approximately equal to 0.574. So we know that that relationship exists, and we know that if we're given one of the values, then that helps us with the value of the cofunction. Okay, part B. In a right triangle, if the secant of if we have the secant of pi over 3, what is the value of the cosecant? So you need to remember the relationship between these cofunctions, secant and cosecant. So I'm going to say the secant of pi over 3 is going to be equal to the cosecant of pi over 2 minus pi over 3. Okay, and that's because in the relationship of this identity, those t's are the same. Okay, let's keep going. So now we have some fraction work to do. What is pi over 2 minus pi over 3? Common denominator would be 6. So I'm going to have 3 pi over 6 minus, what is that, 2 pi over 6, which is 1 pi over 6. Now, sometimes you can't go further without a calculator, but pi over 6 is one of our special angles, so I think that I can. And cosecant is the reciprocal of the sine function, so the sine of pi over 6. And let's see, what is the sine of pi over 6? Do you have it memorized yet? I think it's 1/2. And 1 divided by 1/2 is 2. So the secant of pi over 3, the secant of pi over 3 is equal to the cosecant of pi over 6, and both of those are equal to 2. And finally, part C. In a right triangle, the cotangent of pi over 6 is equal to the tangent of what? And we need our relationship between cotangent and tangent. So I'm going to say the cotangent of pi over 6, so that's my angle, is equal to the tangent of pi over 2 minus pi over 6. And we have some more fraction work to do. Try not to grab for your calculator. I know that you can do these common denominators on your own. Common denominator is 6. Pi over 2 turns into 3 pi over 6 minus the 1 pi over 6. And let's see. 3 pi over 6 minus 1 pi over 6 is 2 pi over 6, which reduces to pi over 3. And we know that tangent, we know something about pi over 3. It's one of our special angles. We know that tangent is made up of the sine over the cosine. I'm running out of room a little bit here. And the sine of pi over 3 is the square root of 3 over 2. And I'm going to divide that by the cosine of pi over 3, which is 1/2. And if instead of dividing by 1/2, I multiply by the reciprocal, the 2's cancel out, and I'm left with the square root of 3. So the cotangent of pi over 6 is equal to the tangent of pi over 3, which both equal the square root of 3.